Warning: copyright notice. This video is protected by copyright laws. Reproduction and distribution or transmitted in any form or by any means, including editing, recording, or other electronic or mechanical methods, without the prior written permission of the publisher, are prohibited.
In this tutorial we'll teach you on how to build a solar panel with 130 watts. Follow our video in a step-by-step tutorial, from raw materials to finished project solar panel. Remember to pause the video when reading an instruction due to the effect of fast forward. May God bless you with wisdom and open mind. Here are the material list: solar cell, soldering flux, PV junction boxes. All of this material are available at www.onesolarx.com. Adjustable soldering iron, solar cell PV ribbon, and solar panel corner guard. All of this material are available at www.onesolarx.com. In this material, you can buy at your local hardware store nearby. Runner wall angle, construction adhesive. We don't intend to advertise the store name, we only guide where we buy the raw materials. In this material, you can buy at your local glass store nearby. Transparent glass with a size of 72 cm by 116 cm and with a thickness of 5 mm. This is a very important reminder of this project. Please do not use all-purpose silicone. Instead, use only construction adhesive. Important tips. If the solar cell has cracked, just use Scotch tape to join together. The cause of solar cell crack: 1. Too much heat from soldering iron. 2. Pressing too hard when soldering the solar cell. 3. Soldering the solar cell in an unlevel area. 4. Dropping the solar cell. Now let us start. Step 1. Solar cell tabbing. Material needed: gloves, to avoid thumb mark on solar cells. Solar cell. Tabbing wires. Soldering lead. Soldering flux for solar cell. Use only this type of soldering iron. The temperature is important and can vary from 360 to 380 degrees Celsius. Soldering iron with temperature control is needed. Do not use this type of soldering iron. There is no temperature control. It can crack the solar cell. Solar cell polarity. All front side are negative. All back side are positive. Preparing the soldering iron. Turn the temperature to 360 to 390 degrees Celsius. Let us open the tabbing ribbon wire and take out the 29.5 centimeters tabbing wire. Prepare the soldering flux. Rub the soldering flux on the solar cell bus bar only. Apply soldering lead only at the end of the solar cell busbar. It may take time to get used to it when soldering the tabbing wires on the solar cell. And do it slowly and do not press too much pressure on the cell. Repeat the process to all remaining solar cell. These are all the solar cell with tabbing ribbon wire. Step 2. Joining the solar cells in series connection. Materials needed. Solar cell with tabbing ribbon wire, buzz wire with 16.5 centimeters, soldering lead, soldering flux and weight. The goal in step 2 is to make one row consist of 7 solar cell in series connection. In every first cell in a row, use 16.5 centimeters tabbing ribbon wire. That can be used later in connecting solar cells in series connection. Rub the soldering flux on the solar cell bus bar only. Apply soldering lead only at the end of the solar cell bus bar. In every first solar cell, use only 16.5 centimeters tabbing wire. It's very important to apply weight on when soldering at the back side of solar cell. This is the gap divider with 2 millimeters wide. Use the gap divider in between 2 solar cell, or you can make your own gap divider as long as it's 2 millimeters wide. Now join the 2 solar cell by soldering the tabbing ribbon wire to the back of solar cell bus bar. This is a focus view on how to join 2 solar cell in series connection. Rub the soldering flux on the solar cell bus bar only. Use a ruler to align 2 solar cell. Use the gap divider in between 2 solar cell. And apply weight on the center of the solar cell to avoid bending of the cell during soldering. This is very important. Start soldering at the sides to lock up the space between 2 solar cells. Remove the gap divider. Continue the process and join 7 solar cell in series connection. This is the finished one-row solar cell, composed of 7 pieces each row. Continue the process and finish the rest of the solar cells. Cut all the excess tabbing ribbon wire for at least 1.5 inches. Step 3. Glass frame preparation. Materials needed. You need to buy a transparent glass with a length of 72 centimeters, with a height of 116 centimeters, with a thickness of 5 millimeters. Clean the glass with newspaper and water. Step 4. Positioning the solar cell on the glass frame. Prepare a gloves. When facing the glass, when you position the solar cell, remember on the right side the output must be negative. On the left side the output must be positive. Focus view. This is our circuit diagram of the solar module with 28 cells. This is a person facing the frame. Starting from the right, the arrangement of the one-row solar cell must be according to the cell output. Negative, positive, negative, positive. Negative output on the right side. Positive output on the left side. Now let us arrange the solar cells. Negative. Positive. Negative. Positive. Observe the photo carefully. Step 5. Securing the solar cell with the transparent tape. Materials needed: ruler, transparent tape and scissor. Secure the solar cell with the transparent tape. See the gap distance guide. Start on the sides. Then on the middle. Secure the rest of the cells. Before we move forward, let us test the solar cells. Voltage should increment. Step 6. Solar cell encapsulation. Materials needed: scissor and transparent packaging tape. Just simply cover the whole body of the solar cell with transparent packaging tape. But do not cover yet the overlapping tabbing ribbon wire. This is important. Make sure that is airtight and no gap. When finished encapsulating the solar cell, cut the excess tape on the side using the cutter for at least 1 centimeter from the edge. Remove the excess tape. Step 7. Connecting the excess tabbing ribbon wire. Materials needed: soldering iron, soldering lead, bus wire with 1.5 mm and electrical tape. Let us connect the excess tabbing ribbon wire into series connection. This area here is our diagram guide. This is the position of person facing the solar cells. Now let us start soldering on the right side. Apply soldering iron. Cut the excess tabbing ribbon wire with scissors. Now we proceed on the middle. Connect the 2 solar cell. Repeat the process. Now onto the left side. Repeat the process. Let us proceed to the other sides of the solar panel. Let us start on the left side. Connect the 2 solar cell. Repeat the process. Then to the right side. Connect the 2 solar cell. Repeat the process. Now is done. If you keep following this tutorial, your solar cell should be like this in series connection. Positive output is here and negative. Step 8. Preparing the busbar wire for PV junction box. Materials needed: marker pen, scissor, bus wire with 1.5 mm, soldering lead, soldering iron, electrical tape and PV junction box. Now let us make a bus wire for our PV junction box. Negative output, positive output on the left side. Use the PV junction box as a guide. Use the marker pen to mark on the surface. And draw a line guide for the bus wire. Use the electrical tape and paste it to the mark guide. Make sure the marked line is fully covered with electrical tape till the edge of the solar cell to prevent from grounding. Mark 3 dots on the surface as a guide. Use the bus bar ribbon wire to create bridge to PV junction box. Use the soldering iron to solder the bus bar ribbon wire. Now make another bridge to connect positive 12 volts output to PV junction box. And also from negative 12 volts output to PV junction box. It is necessary to use a protector cover to prevent the electrical tape from melting when soldering the bus bar wire. See the focus view. Now if everything is set, we have to cover the exposed bus bar wire again with electrical tape. Now let us test if the bus bar wire are properly aligned with our PV junction box. Now we have to encapsulate again the area with the transparent packaging tape. Rub the surface to flatten the bubble. Encapsulate also the bottom side, using the packing tape. Cut again the excess tape 1 centimeter from the edges. Now we finish the preparation for the bus bar wire for our PV junction box. Step 9. Solar panel testing. Expose the solar panel in the sun. During this test, the sky is clear at around 11 in the morning. Step 10. Preparing the metal frame. Materials needed: angle grinder, eye protector, frame cutting guide, gloves, and runner's wall angle. First we need to buy a runner's wall angle. You can buy the runner's wall angle at City Hardware. We don't intend to advertise the store name. We only want to guide where to buy the raw materials. Prepare a table. Cover it with any cloth to avoid scratch on the glass. Put the solar panel on the table. Prepare the frame cutting guide. This is the bus bar ribbon wire for PV junction box. This is how we join the frame together. For rainproof and airproof effective. Observe the video carefully. Cut the metal that is not needed with angle grinder or metal cutting saw. Test the cut frame, if it fits on the frame cutting guide. Test the cut frame, if it fits on the frame cutting guide. Focus view. Step 11. Painting the metal frame. Painting the metal frame is very important to prevent corrosion and rust. Step 12. Binding the metal frame and solar panel glass together. Materials needed. Construction adhesive, C-clamp and metal frames. Don't forget to use only construction adhesive in this project. And do not use general-purpose silicone. Before we start, cut the nozzle this way. Ready the metal frame on the side. Use the construction adhesive on the metal frame. Put plenty of glue on the frame to make sure it's waterproof. Slightly press to spread the glue. Use a wood to indirectly pressing the glass with C-clamp. Repeat the process to the other remaining frames. Let it dry for 12 hours. When the adhesive is already dry, remove the C-clamps. Step 13. Blocking the frame corners with rivets. Materials needed. Plier, hand drill, pop rivet gun. Remove the excess adhesive to flatten the surface. Bend the metal. Make a hole. Use the pop rivet to lock the overlapping metal. Repeat the process. Repeat the process. Repeat the process. Step 14. MDF plain board sizing and cutting for solar panel back cover preparation. Materials needed. MDF plain board, saw, construction adhesive, and hand drill. You can buy the MDF plain board at City Hardware, with a price range from 270 to 300 pesos, buy with a thickness of 3 millimeters. We don't intend to advertise the store name. We only want to guide where to buy the raw materials. Do not use plywood for this project. The plywood will bend in extreme heat. Use only MDF plain board. In this whole MDF plain board, you can use the 2 pieces for your next project. Now back to your solar panel, measure the length and the height. Remember the length and the height from your solar panel, and make a mark to your MDF plain board. Cut the MDF with the saw. This is the cut MDF plain board that fits the back for our solar panel. Step 15. Solar panel back cover installation with MDF plain board. Fit the MDF board on the back of the solar panel. Slide it between the bus bar ribbon wire for PV junction box. Measure the distance from the edge of the frame until the line on bus bar ribbon wire. Transfer the measurement on MDF board and then mark it. Use a ruler and mark it with a straight line. Make a mark according to the tip of the bus bar ribbon alignment. Use the L-square ruler to get the correct straight line. And use a marker pen to make a dot mark. Now it's time to make a hole on the mark area. Prepare the construction adhesive. Spread the adhesive on the edge of the glass. Spread the adhesive to the whole edge of the glass. Make sure the corner is properly filled with adhesive. Now that the adhesive is set, fit the MDF board to the frame. Make sure that the bus bar ribbon wire is coming out on the hole from MDF board. Now that it's finally set, you can press the MDF board to fit on the frame. Sealed it with adhesive. Step 16. Protecting the MDF board. Materials needed: PV junction box, construction adhesive and tarpaulin. Use a PV junction box to make a guide mark. Cut the tarp according to the size of the frame. Fit the tarp on the frame and make a hole for the bus bar ribbon. Measure the distance from edge of the frame to the bus bar ribbon. And copy the distance and mark it on the tarp. Cut the tarp with small hole. Apply adhesive on the marked PV junction box guide. Then on the edge of the MDF board. And spread adhesive all over the body on the MDF board. Now that the adhesive is set, we can now cover it with tarpaulin. Massage the area to spread the adhesive. Let it dry for 6 hours. Step 17. Junction box installation. Materials needed: PV junction box, blade cutter, marker, scissor and construction adhesive. In this PV junction box, we need to connect the 3 terminals to the bus bar ribbon. First we need to mark a guide again, using the PV junction box. Cut the mark area with blade cutter. The adhesive must be directly applied on the surface on MDF board and PV junction box. Let us check the voltage and the polarity. If everything is okay, now we need to join PV junction box terminals and the solar panel bus bar ribbon output terminal. Use a soldering iron. Now it's done. Let the adhesive dry for 12 hours. This is the circuit diagram of the solar module with 28 cells, 130 watts, 14 volts and with bypass diode. Step 18. Installing the corner guard. Materials needed: construction adhesive, 4 pieces corner guard and drawing clip. Let's start. First put adhesive on the join corners. And take 1 corner guard. Spread the adhesive just like in the video. This is the right way of spreading the adhesive. Now place the corner guard on the metal frame. Repeat the process the rest of the corners on solar panel. Use the drawing clip to keep the corner guard in place. Let the corner guard dry in 6 hours. Step 19. Solar panel testing. Now let us test our solar panel and expose it to the sun. Test 1. The time of our testing is 4 p.m. and with a little shade. Focus test view. This is our finished project with 130 watts 14-volt solar panel. Remember this. Make one so that you can make many. If you have any questions, please feel free to contact us. You can visit us at www.onesolarx.com. Our Facebook at facebook.com/onesolarx. Thank you for watching. And don't forget to share. May God bless you with wisdom. One Solarx. Build your solar energy.